Currently, I just started as a researcher 2 weeks ago, but I've been working in the field of wildfires since the beginning of this year. And currently, I'm pursuing a PhD. Okay, wait. But yeah, so during my internship, as the last part of my studies, I've been working with UAV data, more specifically quantifying fuel consumption in heathland ecosystems, and then going towards a multi-scale fuel mapping using remote sensing data fusion. How does it go? Oh. Okay, so as you heard, I'm from Belgium. Of course, Belgium is not the typical country to have extreme wildfires, but it is at least getting more and more recognition. For example, CERAC, the National Crisis Center of Belgium, they are noticing the importance of it, since Belgium is really a fragmented landscape, but it also has a very dense population, so a lot of cities in between the forests, and therefore it's a bit atypical. You can't compare it to Australia, where you have like huge amounts of space, where you can actually almost let the forest go, or yeah, that's a bit more difficult. In Belgium, you have to be very fast and more rapid. And in Belgium, we don't have such a rich history of wildfires. Therefore, there's a lot of lack of data and also monitoring. But that's, of course, also a bit of a light at the end of the tunnel, because a lot of funding now is going towards wildfire research in Belgium. And thanks to that, I'm here in Corsica, and I'm very happy to be hearing all of these interesting methods that everybody's working with. Myself, I published a paper on prescribed burning, in which, yeah, prescribed burning is a management tool which is often used in Belgium to maintain the heathland ecosystems and to lower the carbon rates within the area, and so to lower the wildfire risk. Over here was my study area. Here you can see a few trees, some grass, and some heather, and we will be discussing this area a bit further. So what we did was to fly with the drone over and capture the RGB values, and also with LiDAR we flew both before and after the prescribed burning. And with this, we are able to get an estimation of the vegetation height, but also of the burned volume. For the data processing, we used simple linear iterative clustering superpixels, and then we were able to use k-means clustering to identify the vegetation types. So this is more or less what we got to see. The green line is post-fire, and the purple line is before the prescribed burning. And here you can see a small dent. For example, here you had shrubs, and they had been burned down. And yeah, at the tree here, for example, it's also a bit more difficult, because we were working with a resolution of, I believe, 70 centimeters per pixel, which is actually a bit too high, because sometimes if your coordinate system is not accurately presented, then it's possible that in the first flight we will capture a branch, and the second flight we won't capture a branch. So you will get a huge spike in vegetation loss or gain after or before the prescribed burning. So here you can see the area after the prescribed burning. As you can see, the trees, they more or less maintain their color, and the rest has become gray. And here you can see the results of the superpixel classification. The purple indicates the heather, the green part represents the grass, and the yellow part represents the trees. Overall, this classification worked really well. Of course, you have to put it a bit into perspective, because it was only a relatively small area. And yeah, we had a lot of ground truth points just to make sure our validation was correct. When we go take a look at the superpixels, it's very interesting, for me at least, to take a look at how they work. And through the k-means clustering, we are able to get like the RGB average values, and also with the vegetation heights. With the trees, of course, it's easy to get distinguishments in vegetation heights, and with the difference between grass and heather, you can just purely base it on the RGB values. Here you can see the difference, or like the more or less the estimation of the biomass that was burned. Here you can see the original datum going from 0 to 13.5 meters that has been burned. Of course, this is not possible, and most of the higher values was, of course, because of the trees, as I explained before. And in general, the burnt distribution of the vegetations, they were at around 0.5 meters. If we go take a look at the differences between the vegetation types, you can see that heather had a significant higher volume that had been burned, while the grass and the trees more or less had the same. It's important to note that when we say the trees, we only captured the grass under the trees, and the trees itself we cut out. Overall, this was relatively basic. For me, it was a very nice starting point to get into the field of wildfires. And currently, we are working on a project to estimate the carbon levels before and after the prescribed burning for next year. But as well, with the SLIC method, I think it has some promising results for if we will be working with larger data sets. And one of the future projects has already been started. I believe it was this year, yes. The fuel fusion project, in which we want to tackle the problem of high-resolution fuel type data classification using UAV data. And that data collection we already did this summer. We did this by using UAV data, but we also, UAV data consisting of multispectral, LiDAR data, and RGB values. We also went into the field, so already started on work package 3, validation of the field type maps, and I will later show the results of it. But the main purpose is to actually try to upscale the resolution. So going from drone data to airplane LiDAR data, and then generally going to satellite data. For the multispectral, we can use the Sentinel-2 data. For the others, we can also use Sentinel-1 and the GDI data. In general, we use the classification system of Aragoneses, in which we focused mostly on generalizing the broadleaf deciduous forests and the needle-leaf evergreen, since that's the main forest type that exists in Belgium, but also then going from the low shrublands, medium and high, as well as the grasslands. But all of the rest, for example, the peatlands, we left out of it. Currently, we are at this step now, using deep learning models to try to segment our point data and to actually characterize the fuel type models and using the forest point nets. We have had some promising results for the UAV data, not for the airplane LiDAR data, because we're currently downloading it and it's taking a bunch of time, and it's a very fun process to work on. Here you can see a map purely based on the UAV LiDAR data, in which we'll have candidate labels, and one of our models indicates, for example, high shrub or medium grass or either a medium shrub. And this model can give us an idea of where we want to go. Each of these pixels are 5 by 5 meter resolution. So this model was really useful to take a look at when you go into the field for the validation, you don't have to draw it all by yourself. We also looked at the overstory and the understory labels, and our model worked relatively well. And yes, but yeah, this is all relatively also preliminary data. So I'm very happy to hear about your recommendations, where to guide me, and yeah, thank you very much for your time.